So this object phi, remember what is it? We wrote out part of it here. It's how much each industry spends on intermediate inputs as a function of their cost. Well, if you go onto the Bureau of Economic Analysis, if you go onto their website and you look up their input-output tables, and in particular the use table, what you'll find is a table that tells you the numerators. So you'll find in that table for every industry, how much do you spend on intermediate inputs for every other industry for various different levels of industry granularity. So every 5 years as part of the economic census, although it's typically released much later, they prepare a large input-output table that's typically about 400 to 500 sectors. So quite detailed. At an annual level, they use additional data to prepare a table for a much smaller set of sectors. I think now it's about 80 sectors, to incorporate the fact that the shares do change a little bit year over year. Now, one core thing you'll notice, even in the really granular tables, the 500 sector tables, is that sectors spend a lot on themselves. Often it's the largest expenditure for the sector is intermediate inputs purchased from themselves. So what does that mean exactly? These industries, as you point out, have a lot of firms within them. And so there's actually a lot of supply chains that still exist within an industry. So in the same industry, there's a firm that buys from a firm, and that transaction shows up as the industry buying from itself in the input-output data. As you got more and more granular, your supply chains would look longer and longer. And suppose for these, chair manufacturers, there's actually 2 guys in the petrochemical manufacturing sector and 1 refinery that's before oil. If you had the more granular table, let's say the firm level table, then you would see that their cost share is a 4th order exposure rather than, say, a 3rd order exposure. So I think, the way you think about order of exposure is a function of the granularity of the table. But the point is that this approach is going to capture that at some point. It doesn't matter how long or complicated the supply chain is, it's going to show up here. When it wouldn't in a simple model where you just consider, the chair manufacturing sector's direct exposure to oil. Yes, another question. Plenty of questions.
I was curious about the fact that it seems to me that there's some intermediate inputs and the direct inputs that you're thinking about. But I guess that for different industries there are different intermediate inputs, and so when you pin down that this is exactly always a direct input and then it's always intermediate, is it something crystal clear, or is it context dependent? Of the industry that you're modeling?
Right, so it depends on what you want to do in the data. So you'll see, for example, oil and gas extraction as a sector in the data. But if you want to think about, let's say OPEC has just done something to increase oil prices, and you want to know how that's going to filter through supply chains and propagate to input prices faced by a lot of firms, then you just say, I'm going to consider that industry as a primary factor and look at the propagation of that price movement using this framework. Formally, though, there is a notion of primary factors, though, that aren't produced by industries in the input-output table. So that could be something like labor. Oil in the ground is something that's not produced by an industry. It's something extracted by an industry, although there are ways of producing oil, but that kind of oil is in some ways distinct from oil that naturally exists in the ground. So there is that distinction, but then there's also, from the economist modeling perspective, how you use the model, and there you have a bit more leeway. I think there were some other questions. So
in your empirical work, when you want to compute these shares, do you use this n-step exponential approximation, or do you invert the matrix? So do you take the series, or do you invert the matrix, or how do you?
Yeah, so there's 2 things you can do. It depends on how much detail you want. If the question is just, what is the, let's call it, network cost share for a sector in oil, then all you really need to do is compute this share, this whole share. If you actually want to study it and track the propagation, then you might go to this approach. So you might say, okay, for these chairs, I can run this number. It's pretty easy. It's about 20%, let's say. Then you might say, okay, how certain are you that those costs are actually going to make it to the sector? You can actually look at these terms and say, okay, where is that price increase coming from? What does the pipeline look like? And so if I see that it has to come through petrochemical manufacturers, what I can do is I can keep track of the petrochemical manufacturing prices in the data. And I can say, okay, I'm not worried about the chairs getting more expensive really until I see the petrochemical manufacturing prices going up. Or maybe I should be careful. You shouldn't be so worried perhaps about the costs of the chair manufacturers going up until you really see the petrochemical manufacturing prices, the petroleum refining prices going up. There is a notion here that we're not considering about, are people forward-looking about these things? Do they understand these dynamics and price things in ahead of time? But that's not what we're going to consider today. Yes?
I think wanted to ask a little bit more about that equation. Am I thinking about this correctly, that we need CRS to derive that decomposition? But this analysis seems pretty intuitive. Like, I think the idea that the change in your cost would be your share times price, that's like second.
Mm-hmm.
So if I just wanted some intuition about how should I think of what happens to this if there are other, if there's a DRS going on there.
Right. So you're definitely right that this comes from constant returns, because this gives you a supply curve that's flat. So it shifts, of course, with the input price, but the marginal cost curve is flat in output. If you had decreasing returns to scale, something like that, there will be an output term, a Y term that shows up there. If we incorporated that here, you'd have one for every industry. So you'd have a change in output for every industry. That's going to get to a side of networks that I don't really have time to cover today, but it works entirely analogously. This, what we just did today, is often called forward propagation in supply chains. There's a shock, say, to an oil price. It propagates forward. It's not the best notation because often we talk about consumers as being downstream. So it propagates forward to downstream agents like consumers. Then there's exactly the opposite thing that happens for output. So if the government decides all of a sudden it needs a lot more leather gloves for its military employees, something you can see actually in the government procurement data if you're interested in doing that kind of work. Is that a demand shock for the leather glove manufacturers? And then that propagates in the reverse direction through output using a very similar set of components. But if we had those output terms in the price equations, we'd have to jointly deal with those issues.
But one thing Murphy often does, and we did last week, would be add on another factor that's, some manager or some other factor to make it constant returns. Mm-hmm. And then you might track that. I mean, you might have an S3, S4, or whatever that you're using.
Right, yeah, that's another nice way to handle it. And then, then all of this propagation is really in the price of some of those terms. So it still kind of shows up, I guess, but it's a little bit more hidden, I suppose. And I think in practice, some of those general equilibrium effects are not all that strong, is my understanding. So at least in some of the cases that I've looked at. Yes?
How do we think of propagation if it's like both ways? We think of transportation, storage, logistics, and then the oil sector, and then both of them somewhere depend on each other. And if oil prices go up, that raises transportation costs. And would that be a shock, both a supply shock and a demand shock? How do you think of this?
Yeah, sure. So I could have set this up as a supply chain, and it would have been notationally easier. but I didn't. I set it up as what we call a production network. And so in this setting, we actually allow for all kinds of complicated interconnections. So it could be, let's take these chairs again. Oil prices, let's say, we're propagating to the cost of these chairs. But then it turns out the petroleum refining office workers, they buy these chairs. So now their costs are going up as a result of the chair costs going up. And you have a loop in the supply chain created from that. And that's actually incredibly common in the input-output tables. And this deals with that. So you'll see through that channel, there's like a higher order cost share that these chair manufacturers have in oil due to that particular link being incredibly long. Now, as to the supply versus demand component, I think in a network setting, the easiest way to think about it is just what was the initial shock. It causes a lot of things to happen throughout the economy. There's this price propagation in quantity space. There's firms that are going to be substituting to and from. I like to think about it as just what was the initial shock, and what do you think the initial shock was? Was it a supply shock? Was it a demand shock? And then everything else that comes out of it is a result of it rather than a different kind of shock.
Could you just give an example of like this feature where an industry uses the most from itself, like has the highest share from itself? Because like in the chair case, it doesn't seem like the chair companies are going to be like using chairs as their main.
Right. So this is, I'm pretty sure this is very strongly the case in the petrochemical manufacturing industry. Now, as to the details on why specifically that is the case, maybe there's small changes in petrochemicals that are happening across different firms in that sector, but you can even pull it up if you want to. If you pull up the BEA's use tables, it's a simple Excel file. You can look at the diagonal, that's where it shows up, and you'll see very large numbers there for some sectors, and then you can Google and figure out why that's the case.